Okay, hi teacher. Good afternoon, Engineer Danilo Sikcha. Today, in this moment, I am going to tell about my simulation project in Casimir. My project is called Automotive Welding Process using robotic cyclic industrially. Okay, the syllable which consists in objectives, introductions, theoretical frameworks, developing analysis of results, problems and solution, conclusion, reference. The objectives are in the research on industrial process in which robots can be used. Simulate and program the entire welding process in the custom software. Implement the welding process in real industry. Introduction. The welding process in the automotive industry are constantly evolving from welding began to welding automatically, that is from the first industry to current industry or industrial 4.0, as is now distant to the evolution of production system in the basic of competitive environment and economic and social development of industrial organization worldwide. The materials. Materials is robotic are KUKA AG or KIR 60040, KUKA KIR 350 L280 robotic are in cosmic software. In this case, use the KUKA RJ Auto planets to weld, gripper welding gun or clamp or electrode for welding, bezel able to hold the car, position and approach sensors, pneumatic component cables. Theoretical framework. Here 60040. The advance of the KIR 60040 heavy-duty robots are obvious, powerful and intelligent technology, warrants considerably high production quality without extensive maintenance effort. Compared to previous model, the KIR 60040 stands out with an ever-smile design. The design allows you to hear heavy components up to 600 kilograms in a medium space. The customer software. The customer software is a fairly component and powerful software that can be used not only by professionals but also by students. Science is an excellent modeling and simulation tool for automatic manufacturing process. Spot welding. Spot welding is used for any type of sheet metal, but the most important is found in the mass production of automobile. Spot welding is also used on orthodontic science, when the equipment used is a spot welder, but a small scale has changed the size of metal. Another application is the connection by strap in the welding of batteries. Okay, analysis of results. We can We can observe the correct operation of the conveyor belt when carry the material to the sensors, to later be manipulated by the first robotic arms. Okay, in this picture, here you can see synchronized movement of the arm in chains of the placing the device prior to welding. Okay. We can see how the second arm performs the function of welding the parts. The process will be done twice. Finally, we observe that the conveyor drives the final product to our new sensor, which detects it, and the third process to remove the final product. The latter be taken to a possible and different process. Process completed. Problem and solutions. Okay, we had several problems, among which we were linking and communication the three arms, with projector Suelta, which were solved in this tab, where each arm must have a programming situation and unique positions. A second arms with two projector Suelta, and third arms with tres proyectos Suelta, and copulate. Communication of the three arms. Another problem was when building or design the process in the Cosimer, placing all the objects in different ways to be able to manipulate them in the software without risk of collision. Okay, in here. Conclusion. Successful simulation and programming of a welding process for car parts in Cosimer. We obtained a good connection between loose to control the number of arms and pieces of the process. The method basic for language has made programming easy for you thanks to its easy fast and safe way of programming. Fourth thing, the research exploitation and already mentioned before. And reference. Okay. Next, the simulation of the whole process. Okay, the simulation of the whole process. One arm, proyecto suelto, capillary. 0 errors, 0 warning. Two arm, dos proyectos suelto. Time, 0 error, 0 warning. 0 arms, 3 Proyecto Zelda, copy line, 0 error, 0 warnings. Okay. These positions. This position to arm, this position here arm. I'm programming the arms. Okay. The simulation. Start. And LED indication. Welding. And remember the process. Remove the piles and wind. And the next process. Process with your arms. Okay, finish. Finish process of simulation.